So let's start with the webinar. Today we are going to discuss how secure are ML or deep learning applications. So as you all know that there are a few methods or algorithms that ML applications use, and this is a kind of booming technology these days. So it's been used in various domains, and it's important to discuss how secure are actually these applications. And from a security researcher or pen tester perspective, we also need to have a different point of view to pen test ML based applications. So through this webinar, we'll kind of build an intuition to how to go about pen testing ML applications, what vulnerabilities are there, how to detect them, how to make use of those vulnerabilities to get good results. Okay. So this is how the flow of webinar is. First, we'll understand how basic ML applications work. Since in your chat window, most of us have said that they don't have much experience in implementing ML applications. So we'll just have an introduction to how ML application works, and then we'll have a brief introduction to different attacks and their mitigations. So you can notice here that I have written possible mitigations, if any, because most of ML vulnerabilities do not have any strong mitigation for them. So we'll look at why is this the case. Okay. So as you all know that currently in defensive security also, ML applications are being used in multiple domains. So people are using machine learning to build web application firewalls, intrusion detection systems, antiviruses, spam filters. And besides security, we are also using ML applications for face recognition in self-driving cars, in object detection. So these are so these are the domains where currently the ML applications are being used. Now, this is a kind of abstract idea of how an ML application works. So initially we have one data set, and we use that data set to train a model. So data set is built, some features are extracted from data set, they have samples and labels. Using that, ML engineers and data scientists build a model. So this model, say if you are building a spam classifier, in that case you have a sample set of spam and non-spam emails, and you label those emails and then feed that to ML model, and it will train itself from your data set. So once the model is trained, either you deploy that model to a cloud or you deploy model locally on target device. So it depends on the use case where to deploy the model. So let's say you have uh, a web application firewall. In that case, you need to deploy that model on user's device where the firewall is located. And let's say you have one object detection algorithm, you can have the model deployed on cloud and one API that takes in the input image and tells you what the class of that input image is. So this is an abstract overview of how ML applications work, and we'll look into details of where the vulnerabilities exist and how each point in this entire pipeline can be exploited. So let's start with the first attack, which is called as adversarial learning attack. Now this attack is very well known in ML or data science community. Basically what we do is we take an input sample and make changes in that input sample so that it will be classified to a wrong class. Let's say I am targeting one self-driving car where I want to classify a stop sign as a mailbox so that the car may not stop at the stop sign, and that will be a very unethical use of adversarial attacks. So uh, what you do is you use adversarial learning algorithms to generate an adversarial sample. So what those algorithms do is they add some perturbations to the image. So in this case, we have a sample image and some perturbations are added. If you have some different applications, you could have a different sample, and based on the use case, you can add different perturbations to that sample and you will get desired output. So to do that, you don't have to have a very strong understanding of machine learning and deep learning. there are few frameworks that are already been created by well-known researchers. So there is one framework called as Foolbox and one called as Clever Hands, where you just pass in the model file and give the sample and ask the algorithm to classify that sample to any class, and it will actually make those changes in the algorithm and then make those changes in the sample, and then create a new sample which is called adversarial sample, which is then classified to a wrong class. So you can use these adversarial learning algorithms like FGSM is there. Then we have LBS algorithm. So you can use those algorithms. You can use this framework to implement those algorithms on your input sample uh, to get that sample to be classified to a target class. So this is one way to approach adversarial learning attacks. But a general assumption here is that you have access to the model file. But in some cases, you don't have access to the model file. Maybe the model is deployed on cloud and you don't have the access to that model. So in that case, we have different ways to do adversarial attacks on black box model. We'll look into that in upcoming slides. So here are a few examples of how adversarial attacks have been implemented, and there are some links to the references of these research papers. You can go ahead and read these research papers also. So in this particular paper, they have the results where they can generate adversarial samples by just changing one pixel inside the image. So in this particular sample, you can see that the actual image represents a ship, but just changing the value of this one pixel, it can be classified as car with 99.7% chance. So it is 0.997 probability. So this kind of shows you how vulnerable are these models towards adversarial samples. So this is another objective-based adversarial attack where you can just change few pixels inside the image, which are targeted pixels. So you can generate spectacles out of using those algorithms and use those spectacles to fool a face recognition algorithm. So this is again have been implemented and shown in this research paper. You can go ahead and have a look at this research paper. So here we have an object detection algorithm. So you can see that this person is holding one patch, which is generally called as adversarial patch. So the person that is holding this patch is not being detected by the object detection algorithm. So if a surveillance camera is used, say it is using some kind of machine learning model in the backend and using that machine learning model to detect a person inside the live feed, these kind of attacks can be done to not get detected inside those object detection algorithms. But you can see that this is a kind of a very prominent and a bigger patch that can be that can have like an awkward situation where you are holding it to bypass the algorithm. So it's not necessary that you always go through these complicated mathematical algorithms to generate adversarial samples. There are ways with which you can uh, simply generate adversarial samples without using this complex fancy mathematical algorithms to generate adversarial attacks. So let's see how to do that. So suppose the model is deployed on cloud. So in that case, we are doing black box adversarial learning attack. So how to approach that? So as an attacker, what you do is you create a local model using some sample data set and any machine learning algorithm, you create one local model and then generate adversarial samples for that local model. So just like using Clever Hands and Foolbox or any other algorithm, if you generate an adversarial sample for that local model, it can be used as adversarial sample for your target model. And this has been shown in one of the research papers where you can see the transferability of these adversarial samples. So in this particular matrix, you can see that uh, the source machine learning algorithm here is deep neural network, and say if you have another target machine learning algorithm and 79% of the samples are transferable here. In some cases, it is very you have a very high transferability of algorithms. Like there is a logistic regression algorithm that has been implemented, and it it gives you 91% transferability. In case of SVM, we have 100% transferability, and obviously it is based on uh, the constraint that the paper researchers have applied while implementing the algorithm. So if you want to know more about these constraints and what are the settings that they have experimented with, you can go ahead and check this research paper also. So talking about uh, using machine learning or deep learning in cybersecurity domain. So there, Cyclane has, Silence has implemented deep learning algorithm to identify malware samples. So there was one attack that has been done on these ML-based malware classifiers, so that an input malware sample will be detected as non-malware. And the way they did it is they just imposed few good patterns inside a malware file, and then that malware file was classified as non-malware by target classifier. So as I have said that we always don't have to use these complex mathematical algorithms uh, like they have implemented in Clever Ants and Fullbox to generate adversarial samples. We can have a different approach to generate adversarial samples. The ultimate aim is to generate an adversarial attack, and the aim is not to use uh, or not to complicate the attack process itself. So there is one research paper and framework that's called LIME. So LIME gives you local interpretability of target models. So when you pass an input sample to LIME, it will tell you what are the features inside samples that are responsible for that sample being classified to a target class. So here you can see that using LIME, the researchers have the algorithm has predicted that these are the pixels that are responsible for this input sample to be classified as electric guitar, and similarly. So you can actually use this line for to identify what are the samples in what are the features inside your sample uh, which are prominent for your target class. So there is one example again inside the same research paper where they have created a model which classifies Siberian Huskies and wolves. So if you talk about gray wolves and Siberian Huskies, they both look very similar, but when you generate a model, it was showing a very good accuracy. But the problem with that model can be identified with Lime. So using Lime, you can see that uh, this particular husky is classified as wolf, and the reason behind it is that it just looked at the background of that image. So in the data set, the wolves are wild animals, and wild animals living living in cold places can have icy background in the ice in the background. So the algorithm has just looked at the ice in the background, and based on background, it has classified whether the uh, image belongs to wolf or there is a husky inside the image. So similarly, if you just come to know about the model, that what are the features inside your sample that are responsible for model to be classified to that class, you can just tweak those features and then uh, try to create new samples so that those samples can be used for adversarial attacks. So here you don't have to use any algorithm to generate samples. You just have tweak the sample using manually tweak the sample and then try to create an adversarial sample. So far we have seen adversarial attacks on image classifiers. It can also be done on different classifiers. Like this is the model that I was testing. So we have built one web application firewall, and we have we have given few queries to the web application firewall, and this is the output generated by Lime framework itself. So if you give this query to the web application firewall, it says that this query is a good query, and these are the weightage of every feature inside your query uh, that are that are driving the model to be predict that are driving the model's probability for particular class. So here the words like index, lab, and home and HTML, these are considered as good words by model, and hence the model is predicting this query as good query. And in this particular query, you can see that there is XSS. This is an XSS query, and the model identifies script tag and alert string inside the query, and those are considered as bad queries, bad strings by the model, and hence it classifies that as a bad query. So you can leverage this functionality of Lime to generate adversarial samples. The way you do it is you just append your queries, or insert good samples from, or good patterns from a good query into a bad query, and then you drive the probability of a query being bad towards a query being good. So this is how you manually approach towards generating adversarial samples. So I can see that few people are having questions right now, but you can type in your questions in the chat box. After this webinar, after the last slide, we'll take questions and answer them one by one. So now we are talked about adversarial learning attacks, where you can make model do wrong predictions and use those wrong predictions for, an attacker can use those wrong predictions for ethical or non-ethical reasons. Then there is something called as model stealing attacks. So now, as you all know, that creating machine learning models is a resource intensive process. So corporates or companies use a huge amount of resources, human resource, as well as cloud resources, or technical resources to generate models that uh, and those models can be their intellectual property. But if someone gets access to those models, then that particular attacker would not have to pay the owner of model to use that model, and that could cause an business impact on the product itself. So there are few ways with which you can steal the model from machine learning applications. So one is offline attacks, and the other is online attacks. Offline attacks is when the models are locally stored on your device. You can use basic reverse engineering methods to steal those models. And in online attacks, when the model is deployed on cloud, you have a complete black box access to the models. Still, you could have different ways to uh, get that model. So in offline model stealing, you use basic reverse engineering methods like analyze the serialized model, identify what framework has been used to create that model, then understand that framework and use the functions in those frameworks to load model and generate predictions on your sample, on your own samples. So here's an example of model, serialized model. So this model was serialized and being analyzed by XXD utility in Linux. So once you see the hex dump of that model, you can see strings like torch.nn.spatial convolution, torch.float, which tells you that it is using torch framework to generate the model. So what if we just use Torch framework to load the models from disk to RAM, and then use those models for our own prediction? In that case, you don't have to, you can theoretically have unlimited samples predicted without uh, paying a penny for the owner of that model. So to get the predictions from model, firstly you need to know what are the input specifications that you want to pass to the model. So in this case, if the model is classifying image, you have to understand what is the input size of that image, and you need to know the activations at output layer of the model. So what activation means what class. So there is a mapping file. Traditionally you have a mapping file on disk which will tell you if this particular neuron is activated at output layer in the model, that means the image belongs to this class. So just by looking at the reverse engineered code of the target application, you can identify where the model is stored. You analyze that model, and you also have this mapping file, which is a categories.txt file here. And then just by writing 4 lines of code, you can load that model. So again, you don't have to have a very good understanding of machine learning applications to do that. You just need to have very basic reverse engineering skills to perform this attack. So this is all about offline model stealing attacks. Sometimes you may face issues with loading the model, but again, if you go through the documentation and check why the particular errors are coming, and you can come back and refurbish your code to again load the model. So let's talk about black box model stealing attacks. What if the model is stored on cloud? So you cannot use reverse engineering to get the model. Obviously, you can have some web-based attacks to get access to that model, but let's assume that we don't have any web-based vulnerability which will give you direct access to uh, the storage space where the model is stored. So on web, this is how the classification works. Your model will be stored on some cloud, and you have one API with which users can pass in the input to the trained model, and you get target class for that trained model. So ideally, you get either probabilities of target class, or you just get the target class of that target model. So the way these online attacks works is that, let's say the model stored at cloud is F, and you have to generate a similar model on your end. So the assumption is that you have a set of data which you want to classify. Use that data to you use that samples and get the labels for those samples. Once you have labels, you train your own model and use that model for further predictions. So this is more of a label stealing attacks than a model stealing, but again, you will have a model at your own end, and that way, and the attacker will not have to pay the owner of the original model, which is F here, to get the predictions. So that could cause a business impact on the application. So either you can use traditional machine learning algorithms to train the duplicate model on your end, or at Payatu uh, we have done some research and came up with different an algorithm that can efficiently steal those models or efficiently train the models based on labels. So that algorithm is called as GDALR, which is gradient driven adaptive learning rate. So this is just some mathematics behind the algorithm, and go ahead and check the paper. If you want paper, you can contact me and I'll send you the paper also. And these are the results that we have achieved by using this model stealing algorithm. So here the L represents learning rate, and these are just 2 use cases that we have uh, seen in the research paper. But in research paper, you can go and look at different settings that we have used. So while training the model, what you want to do is you want to minimize the loss so that you get better accuracy on your testing data set. So here using the traditional algorithm, which is represented by the orange line, you get say 0.08 loss, and using our proposed algorithm, you'll get 0.03 loss. So you just look at the difference between orange and green line. The line that is at the bottom or giving you less loss is a better algorithm. So I tested this method on uh, different target algorithms also. So here we have used multi-layer perceptron, or traditional, or well commonly known as a neural network. So again, we have achieved some better results than traditional approach to our proposed approach. And the same goes for convolutional neural networks. So here we are getting very better results, like very good results The reason being that in this particular use case, there were multiple labels. So if you have more labels, you will encounter more unconventional loss in probabilities. And this particular algorithm that we have proposed is actually works on decreasing the loss in those probabilities. So if you have more number of classes, this proposed algorithm will work even better than the traditional algorithm. So just to summarize, we have gone through adversarial learning attacks. So we have seen and looked at black box adversarial learning and white box adversarial learning attacks. Then we have looked at uh, model stealing attacks, where we have seen how to do model stealing when the model is deployed on device or when the model is deployed on cloud. So to perform these particular white box, the black box model stealing attack, you need to have an understanding of how machine learning models are trained so that you get a better duplicate of your target model at your own end. So let's talk about model skewing or data poisoning attacks. So uh, what if we have direct access to the data set that is being used to train the model? In that case, an attacker can abuse the data set. So let's say you have a spam filtering algorithm. In Gmail, so you can see a button where you can mark particular mail as not spam. What that button does is it records your feedback and puts it in a training data set, and a different model is trained on that data, which will classify your particular message as or mail as not spam. So you can abuse, so as an attacker, one can abuse this feedback loop to poison the training data set, and uh, then say the attacker wants to send some phishing mails and it's landing in spam folder, then attacker can abuse this feedback loop and mark its own phishing mail as not spam. So in that case, that phishing mail will be landed in inbox of the target users. So this is what is called as model skewing or data poisoning attacks. Again, say if you have any, say, SQL injection vulnerability in the data set, you can directly send in some false samples in the data set and then cause the model to be skewed. So next is model inversion attack. So this attack assumes that you have the access to model. Once you have access to model, you can use some optimization algorithms to get the data that was used to train the model. So the data could have some sensitive information uh, inside the training data could have some sensitive information. So in this particular example, uh, so this particular research paper, the researchers have generated this sample where they have now you can compare this particular generated sample with the actual sample and see that how similar are the results with the actual sample. So you can actually use the model that is locally stored on your device to get uh, the sensitive data from input sample. Now let's say you have trained one text classification algorithm or text prediction algorithm uh, on a text data set. Again, you can identify what were the samples inside training data set by just typing in some text and allowing the model to predict uh, what are the upcoming text. So let's say a model was trained uh, on a data set that was taken from user, and say the user is always typing my credit card number is some credit card number, and in that case, if you just feed uh, my credit card number is to the model itself, and then it will predict the credit card number. And these attacks have been practically proven to be working in some researches. So you can take a look at this particular research paper called as they quantify this method or the phenomena in neural networks. It's called as unintended memorization in neural networks, and that can be actually leveraged by attackers to get sensitive data from training set. So this is all about the ML based attacks. So these are the final notes. First, uh, the different thing about ML applications than traditional security, defensive security applications is that ML applications actually learn patterns inside the given data set. They do not work on signature based or rule based algorithms. So traditionally in say antiviruses, you have signatures which are then mapped or matched with signatures in the data set to classify a particular file as virus or not virus. But when you talk about ML based antivirus, it will look at the patterns inside the file which are responsible for that file to be classified as malware or non-malware. So based on that, you don't target the signatures, but you target the pattern inside dataset. As an attacker, you can impose some good patterns inside your sample to generate adversarial samples for your target system. Then the way you go about attacking a ML system is that first you identify the use case, identify whether the model is stored locally or it is stored on cloud. How much access do you have to the model? Based on that, you can create one thread model and then uh, go about using different ways to break the application. So one suggestion is that just start using simple methods first. Start uh, trying to tamper with input sample and see how the predictions are being done, and then go by using different methods that has been proposed by researchers. The reason is that those methods you see in research papers are mostly done in very controlled settings, and in real world, many of them could not be directly implementable. So you just go ahead with simple methods and try to identify uh, what are the patterns inside sample, and then use those samples to uh, you use those patterns to generate new samples that could be an adversarial sample for your target class. So this is it from my side. If you have any questions or if you need any help in future, you can contact me at this email ID or my Twitter account. Now we'll take some questions that have been asked in chat section. So one question is that how to detect these attacks? Are there any tools uh, that can be used to detect these attacks? So one thing is that there are tools like Clever and Fullbox that you can use as a beginner. But what I would suggest is that don't go for these tools. Try to build your own tools for ML-based attacks. The reason being, again, those tools are based on a very controlled settings that have been implemented in those research papers. So it may or may not work for you. So if you are generating adversarial samples, I would say try to implement your own methodology to generate adversarial samples and try to say automate it to have a huge set of adversarial samples. Uh, Someone has asked about sharing the slides and videos and code samples for this webinar. We are going to share this on GitHub. You can have a look at Payatu social media handles in next few days, and we'll uh, post the link for slides and video there.
Thank you, Nikhil. Yes, we are definitely going to post about this webinar on social media as well as the YouTube channel of Payatu. So please have a look at that. Have a look at the last webinar as well. That's actually introduction to this particular webinar. And we will also share the slides and links and codes for these webinars as well with you. Any other questions? Yeah, there's a question, Nikhil, in the Q&A.
So any advice for starting with ML security or practical bug hunting? So I assume that practical bug hunting refers to practical bug hunting in machine learning applications. Uh, So the way I would suggest is that you go for basic ML algorithms, or you just try out few projects and implement few ML methodologies so that you get a good understanding of how ML application is built, and then go ahead and try out different research papers and the tools that I've mentioned in this webinar to start with. And again, once you go ahead and start with, you will get a better intuition behind how to use those tools. Yeah. So one more question is that talking about mitigations. Yeah. So for mitigations on adversarial attacks, there are currently no mitigations for adversarial attacks. There are few research papers uh, that propose few mitigations, but they are like not strong enough to be recommended. You can have a set of adversarial sample and train the model again on adversarial sample, but it's a cat and mouse game where you keep on generating adversarial samples no matter how good the model is working. For model stealing attacks, I would say don't deploy your model on your target device, or if you are going to deploy it on user's device, try to use standard data protection methods to protect that model. And for model skewing attacks, you can have model skewing or data poisoning attacks. You can have a golden data set uh, which can be used to verify the accuracy of your model. So whenever an attacker might poison some data set, but when you train the model on that data set, it may not work well on golden data set. So that way you will get to know how the model is being skewed or if the model is being skewed. So these are a few mitigations, but again, there are not any standard mitigation that can be proposed to uh, defend against these attacks. Yeah, so these are
Any
all the
more,
questions.
any more questions? You can ask using the chat option or Q&A option, which is there on the Zoom platform. Nikhil, we got, I think, one more question in Q&A.
Any good source on learning more on ML security? Yeah, I'm going to post the sources also in the same GitHub repository where slides and video will be shared. So you can have a look at those resources. Uh, so to just start with, you can go ahead with any course on internet for ML, uh, then learn about ML security. So first learn about how ML applications are built, then go ahead for ML security. I'll share the specific resources in the repository.
Thank you, everyone. All right. I think these are the questions from the participants. We have one more, Nikhil, actually.
So the question is there any site where labs are available? Uh, so right now, nobody, I think no one has deployed DVWA sort of or a vulnerable ML application kind of thing, because it has different use cases and cannot actually incorporate all those use cases in one application like they do in web application. So I'm not aware of any of such sites where these ML labs are available, but I would say there are many ML based CTFs. You can go ahead and uh, look at those CTFs. So different security conferences have been doing ML based CTFs. Even Nullcon has done it before, and PhDs has done it before. You can go ahead and take a look at those CTF examples and try to solve those CTFs. Yeah, so if you have any more questions, you can contact me on my email ID or on Twitter. I think this is all from my side. So,
Yeah, thank you so much, Nikhil, for this wonderful webinar on the how to secure your ML applications and how secure are ML applications. So thank you everyone for joining us today. If you have more questions, you can ask Nikhil using his email ID, which is Nikhil, Nikhilj @payatu.com, Payatu.com, or you can ask questions on Payatu social media, which are mentioned there on this slide. So just go there and ask your questions, and Nikhil will try to answer the maximum questions. Uh, Also, we will be posting about the recording of this webinar on social media. So keep an eye on that as well. Thank you everyone for joining us today.